still waiting on this side of the room, that back table, and the back. We could do four. Many of them are pretty easy. You define the y-intercept of f of x equals 4x, I'm sorry, 4 to the x plus 2 plus 1. How do we find y-intercepts?
Put 0 in for x.
Put 0 in for x. This is 4 squared plus 1, so the ordered pair is 0 and 9. I'm sorry, I was multiplying, not squaring. Thank you. Alright, make sure you have that written down, and then at some point this week I will check all of those and drop the lowest one, and that will go into a grade vote. Go ahead and pass those up, and take out your right triangle notes.
I don't.
Does anyone else not have those? Because whoever was absent, I didn't put it in your face.
Sorry, I'll take that. I'm working on it.
No?
Here's a funny thought. I was slow. Like stupid.
Yes. Like, it was so lost. What? Listen, he went all the way
You
up
guys
there.
pass these up.
Why did I just throw it away?
Oh, sorry.
Yeah, that's pretty good. I'll just write that down.
Okay, thank you. What is this?
Notes.
Other rectangle? I'm good.
You're good?
Yeah.
Just knock it down. Okay.
Anyone else need those notes?
The same thing. That's easy.
You do.
That's candy.
In what way?
I don't know. What's the word candy mean again?
Like,
Free words.
slow. I'm leaving for
Anyone else?
Exactly. That's if you do it.
I don't think you can. What's it called? Subscribe.
Did we do both of these? Yes.
No, funny thing.
Did we do both of these? Yes.
Ooh,
So we're gonna do one of these, and then do one of these, and then I'm gonna give you the rest of the class to kind of work on them, because they're all really the same. So remember we were talking about the Pythagorean theorem being the same as the equation of your circle, that x, r, y definition, what we use. So that means we have to remember what those x, r, y definitions are for each of these. Someone in the third period asked this, so I just want to clarify. They asked, could we still just draw a triangle with that as our theta and still do like opposite over adjacent? Yes, you could, but the goal here is to try to get you away from doing that so that you remember those x, r, y definitions. So yes, you could do that, but you're hindering yourself also. So for this, what's the x, r, y definition for tangent? Y over x. So this is really y over x. We need to find r so that we can fill out the rest. Remember, you're still using like your Pythagorean theorem. for square cosine. This is 625. So R is 25. This is another Pythagorean triple. Remember I said it might be beneficial to remember these, but not necessary. I remembered the one I was trying to remember, the 3, 4, 5, the easiest one. So now that we have that, we could find everything else. Well, we were given tangent, so that was easy, 7 over 24. Which means cotangent is going to be the reciprocal, 24 over 7. What is the x or y definition for sine? Not x over r. Y over r. So that would be 7 over 25. Which would make cosecant 25 over 7. And then cosine is x over r. So 24 over 25. And then the reciprocal. Yes. In this case, it's a triangle, and you can have negative side lengths. We will talk about negative angles, just we haven't seen that part for this. So if you aren't given a triangle and can't visualize the opposite over adjacent and all of those things, you would do the x, r, y definitions, and the process is the same. Then you have ones like these where you're trying to find a missing side length. Again, shouldn't be too new to you because you've done this before. Using this angle, look at what you have available to you. So in this case, I have some side that is opposite and some side that is adjacent. What trig ratio would we use? Tangent. So we would say the tangent of 75, equals x over 21. And you need to solve for x. In your calculator, you need to make sure your calculator is in degrees. So in mode, change it from radians to degrees if you haven't already. And then round that to 2 decimal places. What was that? The answer, what was x?
78.33.
78.33. I think 37 was right. That's the right number. Mine's not in degrees. Let's try that again. Usually these will be in some unit of measurement. This one isn't. So just put whatever that unit is. So these are very much solved the same way. Sometimes your x is not in your numerator, so think about how you would solve something like that. The last page are application problems, but they're really just those solving the side length problems with applications. So I want you to go ahead and try the remaining problems on this, and then we'll come back towards the end of class and talk about any of these. If you went on ahead and you started these and maybe you're almost finished, I have extra practice on these two up here. And then I will be passing out a homework on this.